Hey everyone, we're going to look at section 7 now, and this is going to deal with base E and natural logarithms. I think that this is one of the more important sections that we're going to cover in this chapter. So we're going to take a look at evaluating expressions that involve the natural base and natural logarithm, and we'll look at solving exponential equations and inequalities using natural logarithms as well. So thinking back to section 6, we dealt a lot with base 10. Just as a quick example, we had log of any certain number, whatever you wanted, 7, and we got some value out of this, and we just assumed that if they don't tell us anything, we have a base of 10. Well, we also have another base, we call that base E, that is also a very common base. And so base E, this idea of E is technically a number. You can plug E into your calculator and get a value. So if I pull up my calculator, you should see a button on here that says E. Mine is right there over the division sign. So I'm going to go second, divide, and I get E. You can raise it to the first if you want. Some of you might have to raise it to the first in order to make this work. But I get the number 2.7 yada, yada, yada for a value. Okay, so anytime you are actually using the number E, you need to think it is just a number that I can plug into my calculator. One of the ideas that we need to discuss is, where does this number actually come from? There's a couple different locations where it comes from. One of the locations that it comes from looks like this, where we take 1 plus 1 over some value n and also raise it to the nth power. This is one way to do it. There's other ways of doing it, but this is the one that would make the most sense from how we've done stuff in this chapter already. This idea looks very similar to the idea of compounding interest, okay, in which it is. We're going to just plug in values for n. I'm just going to say let's plug in a big value to start with. You can plug any values in for n, but let's just say n is equal to 10,000 for now. If you plug 10,000 in for n, 1 plus 1 over 10,000 to the 10,000, that number should get us really close to E. It won't be exact, but it should be pretty close. So we're going to try it. I need parentheses. 1 plus, I'm going to put some more parentheses, 1 divided by 10,000 raised now to the 10,000. Oops, I forgot another set of parentheses. Oh, let me go back. My fault. Try that again. There it is. You can see it's pretty close to that value of E. Not exact, but it's pretty close. So we're going to say that E is really an irrational number. Another irrational number is pi, square root of 2, all of those ideas. But it is pretty close. I'm going to write down what its actual value is. It's 2.7, I believe, 18. Yep, 2.7183 is what I'm going to round it as, is the value of E. Okay, and if you want, we can graph this E to the x. You can see that it is an exponential function, which is what we've been dealing with. Okay, so since it's an exponential function, it should also have an inverse over top of the line, y equals x. And we're still going to say that its inverse is a log. So we can essentially say that its inverse, if I have a function y equals e to the x, that's what we're starting with, that's our base that we're talking about, then we also have an inverse that's going to be y equals log base e of x. Okay, these are going to be inverses of each other. write that in here. Oops. For you guys to see, they're just inverse of each other. So let's go and take a look at its inverse. There it is. You can see that it's an inverse. It's crossing over top of that. It's just reflecting over top of the line y equals x. Now, since the natural log is, or excuse me, since log base e is such a common log as well, we're not really going to write all of this every time. Instead, what we're going to do is we're going to say that log base e of x is the same thing as the natural log of x. It just takes, since e is so common, since it's such a common base that we're dealing with, we're going to shorten that and say log base e is the same thing as the natural log. So now if I go back to my graph for you guys to see, I'm going to get rid of this log base e of x and I'm going to replace it with natural log of x, and it should be the exact same graph as this blue one in here. So if I get rid of it, boom, you can see that it's the same thing. I can put them over top of each other and see how they're exactly the same thing. So whenever I say natural log, you're still thinking of a log base e. They're the exact same thing. So those are the ideas that we're going to look at in section 7, dealing with a base of e and the natural log of x.